guys, Mr. Backerwork here. In this video we're going to look at applying linear equations in two variables. So in this example we're going to look at finding a depreciation value, taking a look at some real estate. So the situation we've got is that a real estate investor purchased a $50,000 apartment building, and for tax purposes we figure out that its value depreciates by $2,000 per year over a 25-year period. And what we want to do with that is write out a linear equation using y to represent the value of the building, and we're going to use x to represent the years after the purchase. So we're writing out a linear equation, which remember looks something like y equals mx plus b. Anytime you've got a recurring cost, in this instance we've got this depreciation value of $2,000 per year. Anytime you've got that recurring cost, we typically look at that as being the slope of our equation, so the m value. Now since we're depreciating, that means we're going down by $2,000 per year. So if we're working on writing out this equation, I'm going to go y equals, we're going down, so I'm going to use negative 2,000 as my slope. And then we've got x in there. And then anytime you have a starting value, so in this case the $50,000 purchase price, we typically use that as our y-intercept, because if we think about it, that's where our graph is like starting. So I'm going to add on the 50,000 on the back end. So that y equals negative 2,000x plus 50,000 is the linear equation representing our building's value. Now I'm throwing another part to this problem at you. It asks, after how many years will the building's value be $24,500? So we're going to use that equation that we just wrote out to try to help us out. Remember, y represents the current value of the building, and we want to figure out when that value is going to be $24,500. So I'm going to plug that in on the left-hand side for my y value. So we've got $24,500 as our y value, and what we're trying to do is solve for a number of years. So we're trying to solve this equation for x. So there's our equation with the $24,500 plugged in. Now like I said, we're solving for x, so we're going to try to get that variable alone. The first thing I'm going to do is get rid of this plus 50,000 on the end by subtracting 50,000 from each side of my equation. Now on the left-hand side, if we take 24,500 minus 50,000, we're going to get negative 25,500. And then on the right-hand side, we still have the negative 2,000x. Now we're trying to get x alone, so we have to get rid of that negative 2,000 that's on the x. So we're going to divide each side by negative 2,000. And on the left-hand side, if we take negative 25,500 divided by negative 2,000, we're going to get 12.75 as our x value. So after 12 3/4 of a year, this building will be worth $24,500. In our next example, we're going to look at finding a linear model to represent Americans' personal income over some given time. So in the table down below, we can see that we're given some years and we're told how much income Americans had during that year. So what we want to do is, it says that we're going to write out a linear equation, and we're going to use y to represent our income and x to represent our years. And it wants us to write out a linear equation using the starting point of 2010 and 12.5 and the ending point of 2015 and 15.4. So we're writing out a linear equation. In the last example, I used y equals mx plus b to help me write out the linear equation. In this example, I'm going to use point-slope form since we're dealing with some points. So remember, point-slope form looks like y minus y1 equals m times x minus x1. The first thing we're going to find is our slope using these 2 points. So remember, our slope formula in order to find m, that's y2 minus y1 over x2 minus x1. So looking at the points that we're given, we're going to go 15.4 minus 12.5 on top. And then on bottom, we're going to go 2015 minus 2010. So across the top, we're going to get 2.9. And on bottom, we're going to get 5. And if we take 2.9 divided by 5, we're going to get 0.58. So the slope of this equation is going to be 0.58. Now we're going to use one of our points, and I'm just going to use the first point as my x1 and y1 to fill into this equation. So this is going to say y minus the y1 value, which is going to be 12.5, equals our slope, 0.58, times x minus the x1 value, which is 2010. Now, I actually want to get y alone, so I'm going to take this 12.5 and add it over to the other side. So for our equation, we're going to get y equals 0.58 times x minus 2010 plus 12.5. Now what we're going to do with that equation that we just found out is use it to make a couple of estimations. We're going to estimate Americans' income in 2012 and also in 2020. So looking at our equation, remember x represents a year. So if we want to estimate for the year 2012, we need to take that and plug that in for our x value. Now simplifying this down, because we're trying to solve for y, first thing we need to do is that subtraction inside of the parentheses. So 2012 minus 2010 is 2. Then if we take 0.58 times 2, we're going to get 1.16. And then lastly, we need to add the 1.16 to the 12.5. So we get a y value of 13.66. Now if we look at our table, the actual income in 2012 was 13.9 trillion. We estimated 13.66. So our estimate is actually a little low compared to what it actually was. Now it says we also want to estimate for the year 2020, so now we need to take another x value and plug it into our equation. Again, starting inside of the parentheses, 2020 minus 2010 is 10. Taking the 0.58 times 10, we're going to get 5.8. And then if we add the 5.8 plus the 12.5, we're going to get 18.3. So we're estimating for the year 2020 that Americans are going to make $18.3 trillion. That's going to be it for this video. Thanks for watching.